In this video, we're going to go over graphing a piecewise function. We have this piecewise function here, which has two segments. The first segment here, and the second segment there. The first segment is the rule when x is between -2 and 2, while the second segment is from 2 to 3. So what we're going to do, since I have two pieces, I'm going to kind of separate my workspace off to the right. I'll start with the first segment. Okay, so this is my first segment from -2 to 2. Okay, so in order to graph this, we need to make sure we find the endpoints for each of the segments. And then we need to make sure we have at least 2 points to be able to graph it. And then we also need to make sure that we check for inclusion versus not inclusion. So first I'm going to go ahead and do the endpoints. These are the endpoints for the intervals. And while the +2 isn't actually a part of this section, it is still the spot that the graph is going to end. It's going to get up really close to the 2, but not actually reach it. So we do need to make sure we indicate where that y value is. So we're going to use both of the endpoints for the intervals to actually graph this. And to do that, we just simply plug our x values in. So the first x value is -2. We're going to plug that into the first piece. So 1/2 times -2 plus 1. 1/2 times -2 is -1. Plus 1 is 0. So my first point that I'm going to have to plot is -2, 0. And because my inequality sign is less than or equal to, it is a solid dot. So -2, 0, solid dot. Now my second endpoint is x equals 2. Is at 2. Now remember, 2 is not technically included, but we still need to use that as the endpoint because that's about where the function is going to be approaching. Just won't ever actually get there. And we'll plug in 2 to our equation or our rule for this piece. 1/2 times 2 is 1. And then 1 plus 1 is 2. So my second order pair, the x value was 2. And the y value, which we just found, is 2. Now this one, because again that it does not have an equal to, will be an open dot. So at 2, 2, we have an open dot. So my guideline said we need to find the endpoints. We just found the endpoint of the interval, both sides of the endpoints. We also need 2 points for a linear piece. This is linear. All of our pieces we're going to be working with are linear. So we have 2 points, so we're good there. So all we really have to do is just connect these. So segment 1 is done. I'm going to move on to the second segment, which is -3x plus 8. And it's on the interval 2 less than or equal to x less than 3. Just like before, we're going to use the 2 endpoints, 2 ending x values. So my first endpoint is at 2. Now this value may not be the same thing as the 2 from the previous segment, so we do have to plug it in. It could be the same, but also might not be. So we do have to plug it in and check to our new piece here. So we're going to plug it into our new piece, -3 times 2 plus 8. -3 times 2 is -6 plus 8 is 2. So it does give us the order pair 2 for the x value and 2 for the y value, which is the same thing as what we had earlier. This time it is a solid dot, so it is going to be plotted at 2, 2, and a solid dot because of the less than or equal to sign. Solid dots take priority over the open dots, so we have now the point 2, 2 is actually a part of the graph. It wasn't before. Everything up to that point was part of the graph, but not 2, 2 itself. But now, because of this green piece, it is. For the other side, x equals 3 is my second endpoint. Plugging it in to the rule, we have -3 times 3 plus 8. -3 times 3 is -9, plus 8 gives us -1. So the order pair is 3, -1. And this is an open dot because of the less than sign. Connecting, and we are good. Okay, in this video we're going to be graphing a piecewise function. This piecewise function has 3 different pieces. So we're going to have to first find the endpoints for each of these different pieces. So I'm going to start with the first one here in green. I'm going to split up my workspace a little bit. There we go. So my first piece is -1 if -3 is less than x is less than or equal to -1. Since we have 2 endpoints, we're going to have to plot both of those. So we need to get the y values that go along with the x values. The first endpoint will be when x is -3. Now this is going to seem a little weird. Remember, to find the y value, we plug it in for x into the equation. However, there is no x with -1. Therefore, when we go to try to plug in -3, the result is just -1. Since there's no x, it is a constant. It does not change, yielding the order pair of -3, -1. This point is an open dot because we don't have the equal to with the inequality sign. So -3, -1, open dot. The next endpoint is at -1. So x equals -1. Plug it into the equation. Our equation is just -1. No x's, nowhere to plug it in. So our order pair is -1 from the endpoint. And then the y value that goes along with it is -1. This point is a solid dot because of the less than or equal to. Now we have 2 points already, so we can graph this segment. And there we go. Next piece. The next piece is x minus 2. It's on the interval -1 less than x less than 0. Our first x value, or first endpoint, is -1. So if we plug that into our equation, we have -1 minus 2, which is -3. So our first order pair, -1, -3. This order pair is an open dot. So -1, -3. Open dot because of the less than sign. On the other end, we have x equals 0. So plugging that in, we have 0 minus 2 to the equation. 0 minus 2 is negative 2. So the ordered pair, our x was 0. We got negative 2 out. And once again, this is an open dot because of the less than sign. We have enough points to graph the segment, so we're just going to connect the 2 dots, 2 points. Now for our final piece. So our final piece is the equation 2x on the interval 0 less than or equal to x less than or equal to 2. Just like the other ones, we're going to use our 2 endpoints. Our first endpoint is at x equals 0. And we'll plug that in, 2 times 0, which is 0. So the ordered pair, 0 on x, 0 on y, solid dot. For the other side, can't have myself there. The other side we have x equals 2. Plug it into the equation, 2 times the x value of 2. 2 times 2 is 4. So our order pair is 2, 4. And once again, it's a solid dot because less than or equal to. 2, 4, solid dot. For the blue segment, we have 2 points already, so we can just connect them. Okay, in this example, we're going to graph this piecewise function. This piecewise function is different from the other ones we've done, mostly because some of the pieces don't have 2 endpoints. They only have one ending for the interval. So they go on and on to infinity. So we're going to have to approach those pieces in a little bit different way. There's 2 ways we can handle it, but we'll cross that bridge when we come to it. Since there is a piece that is similar to what we've already done, let's go ahead and take care of that first. We're going to take care of the middle piece first. The equation is 2 when x is negative 1 less than x less than or equal to 2. Go ahead and take care of this first. So our first x value for the endpoints is negative 1. Okay, and if we plug negative 1 into this equation, there's nowhere to actually plug it in, so we get 2 out. Our first point, negative 1, 2. And this is an open dot because it's just the less than sign. For the other point, at 2, again, we go to plug in x equals 2, but there is no x in the equation, so we automatically get our equation back, and 2 is what we get back. So we have 2 from the x and 2 from the equation. 2, 2 is my second point. Because of the less than or equal to, we have a solid dot. So there we go. We got that segment there. Okay, now let's take care of the first piece. X plus 3. X is less than or equal to negative 1. So just like before, we still need to get the endpoint. This time we're only given one endpoint. So we're going to use x equals negative 1 in my equation. My equation is x plus 3, so it's negative 1 plus 3, which is 2. So this point is negative 1, 2. This is a solid dot because it's less than or equal to. So solid dot at negative 1, 2. Okay, so there we have that first point. But in order to actually graph this line, this segment here, we need at least one more point. So we can do this in one of two ways. And I'm going to do it both ways. Once with this, one way with this piece and one way with the other piece. So for this piece, I'm just going to choose another point and use that to graph it. Since it's x less than or equal to -1, less than or equal to would be on this side of the x value -1. So I just need to make sure I choose an x value that meets the condition of x being less than or equal to -1. So good x value to use, I'm going to go with x equals -3. I can choose anything as long as it meets the condition of x being less than or equal to -1. If I plug this into my equation, -3 plus 3 gives us 0. So my order pair is -3, 0. As for whether it is solid or open, so included or not included, because this is actually on the interval itself, it will be included. So -3, 0 is an included point because it is part of the interval. Now this is the other part that's different. Because this does not actually have a second endpoint, this is just a point on the interval, what we need to do is we are going to start at our endpoint, which is -1, 2, go through the second point I found, and then just keep going. This one does not stop at that other endpoint because of the fact that it's only bounded on one side. There's no second side for the inequality. We have one more piece. So 1/2 x minus 1 when x is greater than 2. So just like before, we have one endpoint. So we're going to go ahead and plug that in. So x is 2 for that one endpoint. So 1/2 times 2 minus 1. 1/2 times 2 is 1. 1 minus 1 is 0. So that endpoint is 2 for the x, 0 for the y. And as far as open or closed, we have just a greater than sign, so it is open. So 2, 0, open dot. Now we are looking at the greater than side. We don't have a second endpoint, so we are looking for the greater than side. So we're referring to this side over here. Now we can do this in one of two ways. In the last segment, I showed you that you can just pick an x value on the interval and use that. I can still do that, but you can also use slope. You just have to make sure you move in the right direction. Slope for this line is 1/2. So we can go up 1 over 2. And because this is not an endpoint, it is definitely a solid line or a solid dot. So you can also use slope to graph the points that are not the endpoints as well. And there you have it.